Good evening, friends. Welcome to the Domain Analytics program. So we were looking at energy and resource analytics. This is the day 3. And today we'll be looking at EDA and pre-processing. So it is a part of our CRISP ML task. We discussed yesterday, CRISP ML. Okay, cross industry standard process for machine learning with quality assurance. So in this, we are having 6 steps as we discussed. First is business and data understanding. Second is data pre-processing, which we'll be discussing today. Third is model building, or we call it data mining step. Data mining or machine learning step, you can say. Next, we are having model evaluation. Next, model deployment. And the last, monitoring and maintenance. Okay, so we are at this step now, data pre-processing. So in this step, okay, we'll try to convert the data from a raw format to a format which will be usable by the next steps. Okay, raw format to a usable format. Okay, we are converting this raw data which we found from this business or their CRM or their sheets and all. Okay, this raw format which we found, we have to convert somehow to a usable format, and this format should be equal. Means we can collect this data from different sources, so it should be made sure that all the data are having the same format. Okay, a same usable format. This will be doing in this process. This process also has not just this conversion, also we see here the properties of data. Okay, when we see the properties of data, it is known as exploratory data analysis. We are analyzing the data, we are exploring the data. Exploratory data analysis. Okay, so we have got this data. We'll see what is the structure of this data. What is the data type of this data? Is this data usable for the upcoming data mining step or model evaluation step? Okay, if it is not ready to be means if it is not ready to be used by the data mining step, so what can we do next? What can we do to convert this into a form, into a usable format? This conversion happens using pre-processing technique, data pre-processing. Okay, there are various data pre-processing techniques we will be discussing. Okay, So let's start. So here today we'll be seeing that exploratory data analysis, various methods we follow here for exploratory data analysis. We'll also see data pre-processing in energy analytics, text pre-processing of a document file. Okay, if you are having a document, how to convert that into a usable format. We'll be seeing other pre-processing techniques also. We'll see. So first of all, EDA. Let's discuss about EDA. EDA, it is having a full form, exploratory data analysis. So here we try to explore our data. Okay, explore the data and analyze it. Okay, so it refers to the critical process of performing initial investigation on data. Okay, so by performing this initial investigation, we can find patterns or spot anomalies. Anomalies here are also known as outliers. Okay, anomalies. Okay, to do hypothesis testing and also to check assumptions, with the help of which also to check our assumptions whether it holds or not, with the help of some kind of summary statistics or graphical representation. Okay, two things we are having: summary statistics and graphical representation. So we'll see both of them. Now EDA, it starts out by asking some basic questions from the data, like the questions we are having here, and this is done to make an initial assessment of the data structure and quality. Okay, once we know this, we can then figure out what to do with the data. Okay, we can plan an attack. Okay, plan a way to convert this data somehow to a usable format. Okay, so what all questions do we need to ask? So here we are having a few. We should ask, is there an existing unique record ID? Is there a unique record ID or not? Okay, so unique record ID are generally used to, identify. It can be used as an identifier. Okay, unique ID will be used to identify a record. Okay, then are there any fields populated with numbers or dates or alphanumeric characters? So what is the data type basically? What is the data type of this field? Okay, what is the distribution of numeric values, whether it is normally distributed, non-normally distributed, what kind of distribution do we have? This also we try to find. How many values exist for categorical field? Okay, categorical field, how many unique values are there in a categorical field? Suppose the gender column is there. Okay, category will be male, female. Now others. Okay, these three, not more than this. Okay, next, how many fields have been left blank, or how many missing value are there? Missing values. So we'll be talking more about this missing values and all. And how are multiple data sets related? How are these two columns related? How are these two columns related? How are these two columns related? Okay, relation between columns also we need to find. Okay, this relation will be used means for some of the algorithms, this relation is quite important to find this relation. Based on that only we will decide whether or not to do any pre-processing or not. So these are some of the questions which you need to ask during pre-processing task. Okay, next. Yeah. So we also said that this EDA consists of two methods. One is graphical, one is statistical. Okay. Graphical methods. Okay, in this we try to visualize the data, and by visualizing it, we try to find out meaning from this visualization. Okay, so meaning from this visualization means graphic. When we draw it, when we draw the visualization, this can be done for a single data, single variable, for two variables, even for multiple variables. If it is a one variable, it is known as univariate analysis. Univariate analysis, two variable, these are bivariate. And if it is multiple variable, it is multivariate. Now, what are these univariate, bivariate, multivariate? Let us discuss. So, analysis of a single variable. I'm just having one variable. Okay. So, let us take an example. Suppose I'm having a variable which is weight. Weight of all the people. Okay. Weight of all the people in a class, suppose. So we'll be having certain values of this weight. Based on these values, okay, we will draw a graph. So here we can draw the person and its weight. Weight, person. Okay. So person 1 is having this much weight. Person 2 is having this much weight. So this we can visualize. Suppose 10 records we are having, 10 this graph we are drawing. So here by this, looking at this, we will be finding some, some inferences we can make. Yeah, most of the people are lying within this range of weight. Like this we can find. But what happens when instead of 10, this is 10,000. So 10 records we can easily measure. But if we are having 10,000 records, so it will be something like this. Some of the values it can't even see. So here you will not be able to make any inferences. For this is known as bar plot. Okay. Bar plot. First, let me just give you the name. This is known as bar plot. So if we are having small amount of observations, we can use this. But generally in our data science, we do not have this small amount of observation. We'll have more amount of observations. So in that case, what you can do, you can bin this. Okay, then you can make bar plot. That is one of the method. But generally, we will not use this. Okay, there is a better method to visualize this. This visualization is known as histogram. Okay, so with histogram, or it is also known as frequency plot. Okay, we will be able to visualize the data. So we see that so here we'll have weight here, and this is frequency. So in this range of weight, how many people are lying? In this range of weight, how many people are lying? In this region or interval of weight, how many people are lying? Like this, we are finding. And generally, if we have a simple random sample, okay, so we will find that we are getting a normal curve. Okay, so histogram, from here we can know the data distribution. Data distribution is something we will be easily able to know. Whether the data is distributed normally or not, whether it is skewed or not. Okay. All those information we can get from here. Data distribution. Also, some idea about anomalies or outliers can also be found here. If we are having skewness in the data, that suggests that there is a presence of outlier is there. Okay, anomalies also we can detect. Third, we are having something known as box plot. Okay, this is also a univariate analysis. In this, we draw something like this. So this middle part box, this has around 50%, not around, this is exactly 50% of the data contained in this. Okay, and equal amounts of data will be present here, and 50% means half of this, half of this, half of this. Okay, each will contain 25%, 25%, 25%, 25% of the data. Okay, this is the box. These two are known as whiskers. Okay, and the middle portion is also known as IQR, interquartile range. Now this is what we use to calculate the boundaries. Okay, and if any point by chance lies beyond these boundaries, these are known as inner fence. Okay, it is 1.5 times IQR. Okay, this length is 1.5 times of IQR. This length also 1.5 times IQR. Okay. Yeah. So from this we find the inner fence. Once we found this, if any data points is lying beyond that, those will be outliers. Okay, these will be outliers, both side. Okay, not just single side, both side. If any data points lie beyond this fence, they will be outliers. By this we can detect outliers. Here the main aim is to find outliers. Okay, here also we can detect data distribution also we can detect here. Okay, so this box, okay, if it is lying a bit this side, that means data is skewed. If it is lying this side, then also data is skewed. If it is in the center, then data is normally distributed. Okay, so this is all about univariate analysis. Okay, this is all about univariate. Now next we are having bivariate analysis. So bivariate means two variable analysis. Okay, here we will be having two variables. This is generally represented by a scatter plot. Scatter plot. Okay, in scatter plot, what happens? We are having two variables, v1 and v2, suppose. Okay, so we will just suppose for the first record, value of v1, value of v2 will be plotted. Okay, suppose this is the point. Similarly, this is the point, this is the point. Like this, points will be plotted. Okay, so from this, from a scatter plot, what all we can find? Okay, we can find what is the correlation, what is the relation of v1 and v2. v1 v2 correlation we can find. Whether there is a relation, whether there is not a relation, is it positive relation, is it negative relation, then what is the strength of the relation, we can find all of this. Okay, so let me just show you. So if our data is somewhat like this, suppose this is a positive relation. Positive in the sense v1 and v2 if you are having, with increase in v1. So you can see as v1 is increasing, suppose from 1 to 2, V2 is also increasing from 1 to 2. Okay. So as both are increasing together, this is a positive relation. And if the data points, our data points lie closer to this line, okay, it will be a strong relation also. So it will be a strong positive relation. Okay. Strong positive relation. But suppose our data points are dispersed, more dispersed. Okay, then it will be a moderate or weak positive relation. Moderate or weak positive relation. Positive correlation. Okay, this is for positive. If suppose we are having a relation like this, that means, so let's see, with increase in V1, so V1 is here, okay, V2 1 is here. So suppose this is 1, this is 2. From 1 to 2 when it moves, okay, so you can see V2 decreases from 2 to 1. When we increase, so we are here, when we are increasing means V1 we are increasing from 1 to 2, this place, okay. So V1 was first here, we increased it to 2, from 1 to 2, so we got to this place, but V2 that decreased from 2 to 1. Okay, so this is a negative relation because increase in one results in decrease in the other. Okay, so this is this line or this kind of relation, if you are having, this is a negative relation. If the relation is negative, okay, again we will check the distribution of data. If it is more dispersed, it will be strong, weak. If it is more closer to this line, it will be strong. Okay, so like this we can measure the correlation. And suppose if we find this and we see no relation between these two, okay, so data points are randomly here and there, we'll say there is no correlation. Okay, this is also one of the facts. Okay, bivariate analysis we can do like that. Next is multivariate analysis. Okay, so what to do if we are having multiple variables? Okay, I forgot to tell you one more thing. In this scatter plot, okay, we may also be able to find the presence of clusters. Okay, suppose the data are like this, we can see these data are closer to each other than this data. So we can also here find the presence of clusters. Okay, so these two can be clustered together. So if we are doing an unsupervised learning model, this can be used to find the cluster. Okay. Now multivariate. So multivariate is multiple variables will be analyzing together. So how to do that? So we cannot analyze. So if we are having two variables, so 2D data up to 2 dimension, it is okay. But what about more than 2 dimension? 3 dimension also. We are having some libraries by which we can measure 3 dimension also. But suppose we are having 10 variables. How to measure 10 dimension data? 10 dimension data is very hard to measure. So what we do in multivariate analysis, okay, multiple models, suppose we are having 5 variables, suppose, so 1, 2, 3, 4, 5 variables, 1, 2, 3, 4, 5 variables. So what we'll do, we will find this 2D, okay, 2-dimensional analysis we'll do, but with multiple variables. So one will be, measured with 2, with 3, with 4, with 5. Similarly, 2 will be measured with 1, then 2 with itself is same, 3 with 4 with 5. Again 3 the same thing, 4 the same thing, 5 also same. Okay, like this. So if there are multiple models in this, but suppose we are using pair plot. So this pair plot, it shows us with itself, it will just show you the histogram, and with others, it will show you the scatter plot. Okay. So how is 112 related? We can see using scatter plot. And now already we know how to find this relation in scatter plot. So we'll use that again here. So here it is not actually multiple analysis together. It is two-dimensional analysis, but multiple two-dimensional analysis are going on simultaneously. Okay. So this is multivariate analysis, where we analyze multiple variables to determine the interrelationship between them. Okay. Examples are pair plot. This is what pair plot is, in which we have histogram and scatter plots. We also have heat maps. So heat maps, they show the relation based on colors. Okay. If it is a more darker color, it is a positive relation. If we are having lighter color, it is a negative relation. Okay. It also depends on the color map. So these are the default values. If you change the color map, this color, this positive, negative, they might also change. So it depends on you actually. Statistical analysis. So we learned about the graphical part of the exploratory data analysis. Now let's move on to statistical part of data analysis. In statistical analysis, we measure this using 4 moments of business decision. Okay, 4 moments of business decision. Here, the first moment of business decision is measures of central tendency. So here we try to find one value which will summarize the whole data. So generally, to summarize the whole data, we take the value mean. So here also we will take mean, also median and mode. Okay, mean, median will be used for numerical data. Numerical mode can be used for categorical data. Mean and median, when we'll use mean, when we'll use median. So whenever we are having anomalies in our data or outliers in our data, we'll use median. Okay, because mean doesn't work well with outliers. If there are no outliers, then we can use mean. Okay, if anomalies are there, median. If anomaly is not there, we can use mean. So mean is actually a better measure than median, but in presence of outliers, median is a better measure. So this will generalize our one value which will represent the whole data. Second moment is measures of dispersion. Okay, so in first moment, we were not able to capture how much dispersed the data is. Suppose, okay, this is my data set, mean is here. We are having another data set like this. Okay, it also has the same mean. So we will not be able to differentiate between these two, graphs or these two data distribution. Okay, just using the first measure. So here we'll be measuring this width. Okay, or how much the data is dispersed, or how much it varies from the mean value. Okay, this we are not able to capture in the first moment. We are capturing this in the second moment. Now this variance or this varying or this variation from the average value is known as variance. Okay, variance. But the problem, there is a problem with variance. Actually, it is our value x minus the mean value x bar whole square. Okay, we do whole square because we don't want the negative values. We don't want this negative value, so we do whole square, so that all the variations can be added to find the total variance. Okay, so the problem here is our units also get squared, but we don't want this, so we do square root of all the values, square root of this summation. Okay, if we do square root of this values, we will get standard deviation. Okay, this is nothing but square root of variance. And also we have something called range, which is nothing but maximum value minus minimum value. So this is second moment where we also capture the this width. Okay, but till now we are considering that everything is normal, the data is normal. What if the data is itself not normal? Data is not normal means we are getting something like this. We may be getting something like this. Okay, normal data will be like this, but we are getting something like this. So our data distribution is not normal. So many data types or many data mining modules, they require data to be normally distributed. So for them, we need to again find if the data is normally distributed or not. And after that, if it is not, we need to somehow transform the data into a this normally distributed data. So here, in the third moment of a business decision, we measure the asymmetry. Asymmetry means if our data is normal, okay, it is symmetrical about me. But if our data is not normal, it will not be symmetric. Okay, in that case, we will have to measure the asymmetry. How much skewness is there? Okay, this is known as skewness, asymmetricity, you can say. We measure this skewness. And some things to notice here is if you are having a long tail here, that means outliers are present here. And also mean is always attracted towards the outliers. So mean will be here, followed by median, mode. Mode will always be the highest point. Okay. So this value is mode. It will always be the highest point. Okay. Similarly, if you are having this kind of skewness, this is known as negative skewness or left skewed also. You can call it left skewed also. Suppose we are having a skewness like this, means there are outliers here. Again, mode, median, mean. Mean will be always attracted towards outliers. This is known as positive skewness or right skewness. Okay, so you can remember wherever the tail is, that skewness it is. Okay, now we are able to measure the non-normality, the centrality, the dispersion, but we are not able to measure. So if you are having a data like this, and if you are having a data like this, suppose, okay, mean median is same, skewness is same, this dispersion is also same, suppose. So how to know the difference between these two data? Okay, so we are having a fourth measure, which is measure of peakedness. So using this peak, okay, or tailedness or this tail, okay, we can measure the difference between two. So it is known as kurtosis. Okay, in this we are having three cases. Kurtosis, if we are having a high peak but narrow but high peak and thick tails are thick. Okay, this means there might be outliers here. Also, this means if you are dealing in stocks or something, this means this is high risk item. Okay, so this is known as leptokurtic. In terms of kurtosis, in kurtosis terminology, it is known as leptokurtic curve. Normal is known as mesokurtic. Okay, and suppose if you are having thin tail, okay, and also low but wide curve, it is known as platycut. Okay, This is known as leptokurtic. It is also positive kurtosis. This is zero kurtosis. This is negative kurtosis. If the kurtosis values comes out to be zero, it is normal. If it is positive, it is leptokurtic. If it is negative, it is platykurtic. Okay, so that was all about EDA. From by doing EDA, exploratory data analysis, we can find the shape of the data, if it needs any pre-processing done or not. All those details we'll be finding from them. Now, let us discuss pre-processing techniques. Okay, so pre-processing techniques, generally data, okay, it will not be present as a table form. It will not be present in a tabular form. So we need to somehow convert this into tabular form. So generally our data is present as text. Okay, so this text data we now somehow need to convert into a numerical form or this tabular form. Okay, so that can be done using text pre-processing. Okay, so energy data or energy text, they it involves automatic extraction of semantic information from archives of documents, contracts, or bills, and using linguistic, statistical, and machine learning techniques, we can do this text pre-processing. This text will be converted into a digital form, and this digital form text will be now converted somehow to a DTM, document term matrix. And using this and something known as TF-IDF, we'll be able to convert them into a data set. This data set, also known as a TF-IDF vector, TF vectorizer. Okay, this will have all the terms in our document and its value like 0, 1 value, whether present or not, or how many times it is present. Okay, so using this, we can easily convert a text file into a structured format, and then once it is done, we can do further calculation. Okay, so for this we have various tools like BERT, SPACY, NLTK. Okay, this is natural language toolkit, which is used for NLP tasks. And after extraction, the data now needs to be cleaned. Okay, once we have extracted the data, suppose we are extracting this from a website. Okay, once we have extracted the data, then we'll have to clean it. After cleaning, we'll tokenize the data. Tokenize means convert it into a lower form. So if it is in form of sentence, suppose, it will be converted into words. Now on these words, we can directly work on. Okay, normalization, which is converting of multiple forms of word into single form. Noise removal, various other methods by which, if it is suppose having typos, or suppose having punctuation marks or some words which we do not need, okay, we'll have to remove all of those. Okay, so general outline, if you see, if you are extracting data from suppose a website, we can remove the HTML tags present in the in the extracted data. This extracted data may contain some tags also coming up. So we need to eliminate these HTML tags. Extra white spaces, if there are white spaces, we also need to remove them. If some accented characters like ASCII characters are present, accented characters are there, we need to convert this into ASCII characters. Okay, other format characters, if there, we need to convert this into an ASCII form. Okay, we will also have to expand the contractions. We will have to remove special characters like special symbols and @ if hashtag, if These are there, we need to remove them. Okay. Then we'll also have to convert all our text to lower cases. This is done because our dictionaries, by default, whichever dictionaries are there in NLP, all are present in lower case. So the comparison cannot be done unless all the text are in lower case. Okay. So for that, we need to convert this all to a lower case. Now converting number of words to numerical form also we'll need to do. Okay. Means if you are having suppose 9, but it is present as a string, we need to convert this to a proper 9, which will be an integer. So first it was a string. We have to convert this into an integer. Okay. We'll have to also remove numbers. Suppose some numbers are there which are unwanted. We'll have to remove them. Stop words. So stop words are filler words like a, and, the, and. Okay. Means the words which will be repeated again and again. We don't want this to be in our data set because they will steal all the glory. Okay. This a will be present multiple times, more than the times other words are present. So when we do this TF-IDF vectorizer, this will have the most value. Okay, it will be the most important one. So we need to remove these commonly occurring words. Okay, because we don't want to give them importance. We will give the importance to those words which matter in our text. Okay, we are also having lemmatization, in which if a word is having different forms, like if we are having jumper, jumping, jumped. Okay, if we are having all this, it will convert all the word into a single base word. Okay, so this is how we do it. Okay, friends, so now let us discuss the few pre-processing techniques. Except that text pre-processing, what other methods do we have? Okay, so let us discuss. First is typecasting. Before going to typecasting, okay, this comes under something known as type conversions. Type conversions are of two types: explicit and implicit. So explicit conversions are those in which we manually convert the data into a different data type. Okay, this is explicit type conversion. Implicit type conversion, in this automatically the types are converted automatically. So for example, if I say, suppose I'm doing 9 by 10. Okay, so this is an integer, this is also an integer, but when we divide, it will be coming as 0.9. Even if we are having a perfectly divisible thing, suppose we are having 20 by 10, it will give you 2.0. Okay, it will give you a float value, even if perfectly divisible. So typecasting is a similar method. It is an explicit method in which we change the type of a column, of a whole column in a data set. Okay, typecasting is a method by which we can change the whole column in a data set to a different data type. Here the function used is as type. So there are multiple other functions, but we have learned as type. So this can be used. Handling duplicates. So if we are having duplicates in our data, we need to somehow remove this. Why do we need to remove duplicates, you may ask? So duplicates, they affect your total data analysis. Your EDA will be affected by presence of duplicates. If your data is normal, presence of a duplicate may change this, may convert this data into a non-normal data. Okay. So this duplicates need to be removed because they change the shape of the data. Okay. So what are duplicates also? Let me say. Duplicates are nothing but once the record is entered, it comes up again. If it comes up again and again, these are all duplicated values. Okay, these values are not required. Only the first value is required. So we'll remove this data. Next is outlier analysis and treatment. So outlier, I told you already. It can be viewed from a box plot. Any point lying beyond this box plot. Okay, those are outliers. We need to somehow treat them. Okay. So here there are three methods. Three R methods are known. They are known as to treat this. So first is remove. Second is replace or rectify. Third is retain. So retain means we'll have to keep the data. Remove means we'll have to remove the data. Replace or rectify means somehow we'll correct the data with a value which is correct for that place. Remove the data. If we are having a very large data set, suppose 1 lakh records are there, and when we found that when we are looking for it, we found that two data points are having error. Okay, they are outlier. So even if we remove this, okay, 2 lakh minus 2, it doesn't affect that one. So in that case, we will remove the data. Replace or rectify. Okay. Suppose this two data set only. We ask the suppose this is a store data. Okay. We were working for them. So we asked the manager, what are these data? So he told you that these are all wrongly inputted data. So we are having the correct values. Please correct them. So they gave us the value and we corrected them. So rectification also can be done. Now retention. Suppose the same case, we are having this data. We ask the subject matter expert that why is there a spike in this data? Why are these values coming up? So the store manager told us, yeah, this is our super Sundays. These are our super Sundays. Here we give out sales, okay, mind-blowing sales, due to which our sales have increased over all the weekends. So he's saying that this will be repeating in all weekends, coming up weekends also. In that case, when this data is relevant, okay, it will be we'll be able to capture this data again and again. Same kind of data we'll be able to capture. So we will now retain this data. It will help us in now predicting the weekend slots or weekend data. Okay, so these are the cases of handling outliers. Then zero or near zero variance. Okay, if we are having zero variance, that means our data is not varying. Data is not varying, data is all same value. If we are having this case where data is having all the same values, we will remove this column because it will not give any it will not provide any importance, or it will not provide any value, we can say, to the model building. Okay, this will just be a simple extra calculation, so we'll just remove this. Next is discretization. Okay, this is a method in which we convert the continuous value into a discrete form. So in some of the models, we need to do this continuous value to discrete form. Okay, this will also, if we are doing this, suppose these values are not that much important, we can also discretize it and use If you are using the discrete values, the calculations will be more faster because now we are having categories. So only 4 calculations instead of multiple calculations will be done. Okay. So this will be easier. It will be faster. This will be easier. Accuracy might falter, but yeah. So that is why I told you, if this is not that much required, then we do. And in decision tree, if you see, okay, we'll have to do this discretization so that they can be divided into different trees or different nodes. Then missing value. What to do if you are having a missing value? So either we can remove the whole column, or we can do imputation. Means we'll put a value which we think might be right for that. Okay, these two methods are there. Then dummy variable creation. So this relates to something known as levels of data. So we discussed this levels of data. There are 4 levels. First is nominal data. Second is ordinal data. Third is interval data. Fourth is ratio data. Okay. So this is the most preferred data. We talked about this. Nominal data, on the other hand, will be the least preferred data because this cannot be used in any statistical calculation. Okay. A very less number of statistical calculations are there in which this nominal data can be used. So for this data to be useful, okay, suppose this data is relevant to our data set, we need to keep this. So this data, to capture values from this data, information from this data, nominal data, we will have to somehow convert this data into a numerical form without giving them ranks. Ranks means all the data present in nominal data will be in the same level. But if you are numbering them, suppose we are numbering them 0, 1, 2, 3. These now are not in the same level. Okay, 0 we know is lesser than 1, 1 is lesser than 2, 2 is lesser than 3. But here the data is not less or more. Okay, they are at the same level. So somehow we need to convert this into a form. Suppose this is C1, category 1, category 2, category 3, category 4. 4 category we are having. So what we will do? We will just convert this into columns. C1 column, C2 column, C3 column, C4 column. So wherever C1 was there, the value will be 1, others will be 0. Similarly for C2, similarly for C3, similarly for C. Okay, so this is known as dummy variable creation. Next we are having transformation. Transformation is a technique in which we convert this data which is non-normal. Okay, we are talking about this. If we are having skewness in the data, what to do? So that normalizing the data is known as transformation. Non-normal data to normal data conversion. Okay, it is known as transformation. So we need to transform our data into a normal data. So this can be done in multiple ways. The most famous one is log transformation, in which we take the log of input and we take the log and we try to do the ED again. So generally we find this to be very good. There are multiple other ways, but there are 2 more interesting, which is Box-Cox and Johnson's method. Okay, they are most successful methods for converting this or transforming this non-normal to normal data. Then standardization also, normalization is also there in this. These are all scaling methods. Okay, scaling means if our data present, suppose one of the data is in tens, one of the data is in lakhs. Okay, it will be very hard to compare both of them, as we say that all the variables are having equal importance. But if values are like this, equal importance cannot be given. So we need to scale the data down to a certain value. Suppose 0 to 1, this is known as normalization. From we are also having something known as standardization, in which mu will be 0, sigma will be 1. Mu is population mean, sigma is population standard deviation. Okay, these two methods are there. And string manipulation is nothing but somehow we will change this data to our. So data are generally, if we are dealing with text data, which we already discussed, we'll have to somehow do some manipulation to convert this into a form which is usable. So that is done using string manipulation. So these are all pre-processing techniques which we need to follow. Okay, friends. So these are some of the methods which we should be doing in our upcoming sessions. Okay. So next sessions will be delving into model building parts, data mining. Okay, we'll be seeing this model building. So in this, we'll be starting with clustering first. Okay, clustering techniques, the unsupervised machine learning techniques, unsupervised. We'll be seeing this tomorrow. So yeah, thank you, friends. We'll be ending our session for today now. So thank you, everyone, and keep learning, and yeah, have a great day.